This is a debate regarding productivity in the Australian construction industry by James Bolton Barracan, David Vasey, Michael Kay and Jacob Brudenell. This debate centres around the argument that the adoption of general manufacturing principles is the most valuable method to improving productivity in today's construction industry. First argument 4 will be conducted by David Vasey, arguing that the use of off-site manufacturing principles provides a streamlined method of production of construction or building elements and delivery of a project.
Off-site manufacturing in terms of construction involves the fabrication of elements in a factory environment and transported to site where it is installed. Off-site manufacturing includes the adoption of a production line process to efficiently manufacture a product by adopting lean manufacturing principles. These include optimizing waste reduction, reduces the number of processes or steps, process and supply chain control, constant benchmarking, improvement of the efficiency of the process, reduce cycle times and increases process transparency, recognizes the interdependency of activities through the production process. There is tight coordination of the entire process from design to fabrication and adopts a more scientific approach to production management by assessing product flows and processes. Argument 1. Traditional construction methods are very wasteful in material and inefficient in labour. For example, often material is ordered in standard lengths or sheets, then extra labour is required to cut the size and waste is thrown away and rarely used on another task or job. For off-site manufacturing, as discussed in this introduction, is not wasteful and creates a streamlining effect on fabrication. As stated by Gibb 2001, there is a great adoption of lean manufacturing where the same processes are able to be completed more rapidly, limiting delays and overall lead times. This can produce an overall reduction of on-site construction program. Industrializing the manufacturing of the same construction item in a factory environment is faster due to less time wasted from inefficient factors, such as moving materials around site and traveling to task areas on large sites. The controlled factory environment also eliminates on-site construction risk delay, and workers are able to complete the same task by operating at a safe working level in a single work area, eliminating working at heights or any awkward spaces. Argument 2. The process of fabricating items is simplified and can be introduced into the whole construction process, as stated by Blesmers 2007. As we are seeing more of today, off-site manufacturing is making its way into construction in bigger and better ways, with whole apartment buildings being constructed by smaller off-site manufactured modular elements. The opportunities for off-site manufacturing in construction is endless. Off-site manufacturing means improved efficiency in installation on site, as stated by Pasquale and Conley 2002. Through installation of prefabricated larger elements, many trades can be eliminated from the on-site process. If we look at bathroom fit-outs, which are notoriously trade-intensive, can become very inefficient on-site if trades are not coordinated properly. By production bathroom pods utilising off-site manufacturing, we can eliminate up to 12 trades in the fit-out process. In conclusion, we have discussed modern lean manufacturing principles used in off-site manufacturing and how the adoption of off-site manufacturing has the ability to reduce on-site construction time through streamlining of the same fabrication processes in a more controlled manufacturing process.
Second argument 4 will be conducted by Jacob Brudenell, arguing that the use of off-site manufacturing allows for greater flow in production, enabling more efficient scheduling of construction programs. The first argument against will be conducted by James Bolton Barracan, arguing that the Australian manufacturing industry does not have the technology, training or demand for the use of prefabricated materials to make it a worthwhile venture.
Hi, my name is James and I'll be arguing the Australian construction industry does not have the technology, training or demand for the use of prefabrication to make it a worthwhile venture. Industrialisation in construction is defined as a rationalisation of the work process in the industry to reach cost efficiency, higher productivity, and quality. It involves a change in thinking and practice to improve production of construction to produce a high quality, customised built environment through an integrated process, optimising standardisation, organisation, value, mechanisation, and automation. The idea of improving performance in construction by learning from other industries, such as manufacturing, where the system of production involving the concentration of materials, fixed capital, and labour in one or more plants has long been perceived to improve efficiency. But stakeholders, including clients, architects, and engineers, project managers, builders, contractors, and suppliers, are unable to make decisions to utilise off-site manufacturing due to the lack of understanding of these processes. There are two examples of the Australian government trying to utilise off-site manufacturing in the housing industry to improve time, cost, and quality. The first was by the New South Wales Housing Commission after World War II. The Commission obtained 200 prefabricated house design proposals and constructed 25 test houses. From those, the New South Wales Housing Commission claimed that prefabricated houses cost more than the orthodox dwelling. The second instance was in Victoria, where the state government converted the Beaufort aircraft factory into a prefabricated house manufacturer. The federal government ordered 5,000 of these at the time, however only 23 were built and it was found they were more expensive. Further to this, there is a lack of knowledge and investment in off-site manufacture in Australia. The stakeholders in the industry, such as contractors, have difficulty ascertaining the benefits of off-site manufacture. Coupled with high labour costs and resistance from the union, off-site manufacture has its detractors. This includes resistance from clients and consultants due to factors such as inhibition of design creativity, increased capital cost, limited impact on critical path, and increased waste through accidental damage. During the Royal Commission, Cole noted the Australian construction has been characterised as adversarial and inefficient and in need of structural and cultural reform. This was over 10 years ago, and it could be argued the construction industry is still in status quo.
The second argument against will be conducted by Michael Kay. The argument will be made that the standardisation of the manufacturing line is a limiting factor for the output of off-site manufactured building elements. Some materials may not be able to be produced identically, as every project is different. The standardisation of the manufacturing line is a limiting factor for the output of off-site manufactured building elements. Some materials may not be able to be produced identically, as every project is different. Standardisation of manufacturing is described as the process of developing and implementing a uniform product. In this case, the standardised product could be any structural element of a building, including but not limited to precast panels, precast flooring, or modular bathroom pods. Smith 2014 defines construction of off-site manufacturing as the process of planning, designing, fabricating and transporting of building elements for assembly on site. To understand the challenges faced by the manufacturing line, we must first look at the potential for the construction materials to be produced on a manufacturing line. We also have to look at whether or not construction materials can be adapted to suit the manufacturing line process. Construction materials are by nature large in size, and generally a production line will require quite a substantial setup of plant and machinery, or large areas of space to cope with these elements. Blissmith 2009 noted that due to the lack of knowledge of construction materials, a manufacturing worker may in turn be less productive even though it is on a streamlined production line. The change from manufacturing construction elements on site to a factory may also cause friction between the manufacturing workforce and the construction workforce. While the lower manufacturing industry pay rates may benefit the contractor's use of the product, the construction unions may fight this change due to the loss of work for their members. This is a definite barrier for the manufacturing line and may cause union strikes, in turn lowering productivity on site. A further reason preventing a standardised manufacturing system being used is the limitation of standardising building elements. Neil M. Cavell 2009 argues that due to spatial restrictions and assembly relationship of each building element, it may be too inefficient to make a standard production line conform to or manufacture a specific product. Commercial construction projects vary in nature, and it is extremely rare to find one building architecturally or structurally identical to another. Specific products can therefore not be standardised to suit multiple projects. Blissmith 2007 identified the need to specifically design a building element as a process constraint. Generally, all structural building elements will be engineered to a specific stress level or tolerance. It is not realistic to assume that they can be made to the same levels or tolerances as each other unless it is found to be highly cost effective. In summary, the nature of the building elements and the current structure of the industry will restrict the use of production line attempting to improve productivity. No two buildings are both architecturally and structurally identical, which will limit the extent of standardisation. Thank you for watching our debate.